Hi guys, good morning. It's another lovely Thursday, and today we are looking at mathematics. Let's talk about some common errors in math, common errors that we might be making, and let's see how we can resolve them. Okay, so now let's talk about opening a bracket with an exponent. So you have a bracket and you have an exponent, outside the bracket. So how does that work? Now you need to understand that if I have xy all raised to the power of n, it's not the same thing as xy raised to the power of n. Okay, what this simply means is that when you have a bracket, that exponent should be applied to everything inside the bracket and not just the term directly in front of the exponent, okay, or directly behind the exponent. So let's look at an example. For example, 5y all cubed is not the same thing as 5y cubed. Okay, this is wrong. Okay, instead what you're supposed to do here is 5y all cubed. So you have 5 times 5 times 5, that will give you 125, and then you have y cubed. So 125y cubed is correct. Okay, so if you happen to have been making this mistake, just take notes and be careful when you see questions like this. Okay, so that's that for a section on common math errors for today. Let's move to what we need to know today. Now, first of all, I need you to remember how to use standard form. I guess you might have done this in grade 9. So if you still remember how to use standard form, we would be reviewing that today. Then we'll be talking about finding the logarithms of numbers, and then we'll be moving on to calculations involving logarithms. So let's start with our topic, logarithms. Wow. Okay, so let's review standard form. Now, a number is said to be in standard form if it can be expressed in the form a times 10 raised to the power of n. Now, I'm going to explain what a times 10 raised to the power of n simply means. Now, a must be a number between 1 and 10. Okay, a is a number between 1 and 10, and then n should be an integer. So if you're saying you want to express a number in standard form in the form a times 10 raised to the power n, a should be a number between 1 and 10, and n should be an integer. Okay, so that's what we call standard form. So let's take an example. Can you express these numbers in standard form? Do you still remember how to express numbers in standard form? So if you remember, you can go ahead and try it out. I'll just do the solution over here. So let's start with 45,600, 45600. So 45,600 is 4.56 times 10,000. Okay, and that gives you 4.56 times 10 raised to the power of 4. I usually say it's almost like you're moving the decimal point. So, of course, there's an imaginary, it's not imaginary per se, there's a decimal point here. Since it's a whole number, there's a decimal point behind the whole number. So it's almost as if you're moving the decimal point. And then the number of times you're moving that decimal point would also determine the integer n. So when we say 1, 2, 3, 4, we stop here because 4.56 is a number between 1 and 10, right? So, but we moved the decimal point 4 places, and this is a large number, so automatically we have 10 raised to the power of 4 here. The next one, 0.0067, is the same thing as 6.7 times 0.001. Okay, you can also say we are moving the point, how many times? 1, 2, 3, because we stop here because 6.7 is the number between 1 and 10. So we move the point 3 times, that determines our integer. But since this is a small number, this is a number less than 1, then our power would also be negative, right? Okay, so we would have 6.7 times 10 raised to the power of -3. Okay, remember that wherever you're going to stop if you're using the moving point method, wherever you're going to stop moving that decimal, the number should be between 1 and 10, and then the number of times you move the decimal will determine what your power, that's your value of n, would be. And if it's a large number, the value of n should be positive. That's if it's a number that is greater than 10, of course the value of number greater than 10, the value of your n should be positive. For smaller decimals, 0 point this, 0 point that, and the likes, your power should be negative. If those basic rules are not reflected in your work, then there's a mistake somewhere. Okay, so always try to cross-check whenever you're working out standard form. Okay, let's go to logarithms. What do you understand by logarithm? What's the meaning of the word? What's the meaning of the word? Now, logarithm, the logarithm of a number is the power to which 10 is raised to give that number. It's as simple as that. If I'm trying to get the logarithm of the number, what I'm asking you is, what power do I raise 10 to give me this number? So, for example, I'm saying, okay, what's the logarithm of 59? What power do I raise 10 to give me 59? That's the meaning of logarithm. So logarithm, the word logarithm is very closely related with the number 10. Okay, so just please take note of that. Let's take some examples. Now, 1000 is 10 raised to the power of 3, right? 1000 is 10 raised to the power of 3. We know that 1000 is 10 raised to the power of 3. Now, log 1000 is simply 3. Log 1000 base 10 is 3. So when you're looking for log 1000, you're saying, I want to find the log of 1000, okay? So that means, what power do I raise 10 to give me 1000? Of course, you raise the 10 to the power of 3 to give 1000. So the log of 1000 is 3. The log of 1000 in base 10, that is 3. Now, you can have logarithms to other bases anyway. You can have logarithms to the base of 4, 5, and the likes, but we're going to be focusing majorly on 10. We're going to be focusing majorly on 10 for the purpose of this class. So logarithms can be given in other bases. Okay, I've said that, except from 10. Now, in general, if you have y equals to n raised to the power x, okay, that simply means that log y to base n equals x. Now, this is a very crucial relationship between logarithms and indices. Of course, we'll talk more on this relationship later on. Okay, but let's continue. So logarithms used in calculations are usually in base 10, and they're called common logarithms. So that's what we're going to be focused on for the purpose of today's class. Now, let's talk about how to find the logarithms of these numbers now using a logarithm table. Okay, so I'll just put a snippet of the logarithm table. I believe you would have your own tables with you, a 4-figure table which contains logarithm tables and so many others. So if you have that, you could look through it and check while we're working. So that was a snippet of the table. We'll be using that anyway for this part. So we want to find the logarithm of these numbers, 3,500 and 242.3. Now we're back with our table. Let's start the solution for number 1. Now, first of all, you must change 3,500 to standard form. So of course, we're going to do some moving of the decimal here. 1, 2, and 3. So we stop at 3.5 because that's a number between 1 and 10, and then that will be 3.5 times 10 raised to the power 3, since we moved the decimal point 3 times. So then the next thing is the first part of our answer will be 3 point. Now this power, the log of 3,500 is dependent on the power now. So the power was 3 here. We got 10 raised to the power 3 here. So this 3 becomes our characteristic. So we say 3 points. Now, how do we get the mantissa? We call it the part after the decimal point, the mantissa. How do we get the parts, the decimal part or the fractional part? You come to your logarithm table and you check 35. Since it's 35.00, you check 35 on the 0. Okay, this is the column for 0, so you check 35 on the 0, and that gives us 5441. 5441. So we have 3.5441 as our answer for log 3500. Okay, I hope you're following. Alright, so let's move to 242.3 now. Let's look at that answer. So 242.3 would involve moving the point that's here 2 times to the left, because we'll stop at 2.423. That's the number between 1 and 10. So we move the point 2 times, so we have a power of 2 here. Now remember that this power of 2 is our characteristic. So log 242.3 is 2 points, and then we go to our table. We have 2, 4, 2, 4, 2, and 3, right? So we check 2, 4, 24 on the 2, difference 3. 2, 4, 2, 3, you check 24. Okay, are you following? You check 24 on the 2, difference 3. So this is 24. Let's check on the 2. That's 3838 and difference 3. So 3838 plus 5, that would give us 3843. Okay, so 24 on the 2, and then you add the difference on the 3. That's 5 here is on the 3. So you add this 5 to 3838, and you get 3843. So our log of 242.3 is 2.3843. Okay, so that's that for using the logarithm table. I hope it's easy for you to understand. You could practice checking for the logarithm of numbers, on your own with your table, and confirm with maybe a calculator to check if you are correct. Now, let's talk about anti-logarithms. Anti-logarithm simply means finding the anti-log of the number. Means you found the log of the number already, and you want to go back to the original number. That's when we apply the anti-log. So this is a table showing some part, just a snippet actually of the anti-log table. You should have tried to get one. If you don't, the table, the log and anti-log table, it's a part of the 4-figure table anyway. So let's talk about some examples for anti-log now. So 0.6241 and 2.5410. So let's look. We have our table. Let's start with number 1. Now 0.6241. Now we will check 62 under 4 difference 1 in your anti-log table. So let's go. 62 under 4. This is under 4. 4.207. Difference 1. Let's go to 1. Okay, difference 1 also has 1 underneath here. We have difference 1, and underneath that we have 1. So that's 4.207 plus 1. That's 4.208. So that's how you check. You check this part, 6241. You check this part in your table. Now, after getting this part, how do you know the power of 10? Of the original number? How do you know the power of 10? It's easy. Just check the value you have here, 0, and that becomes your power of 10. So 4.208 times 10 raised to the power 0 here. Okay, and 10 raised to the power 0 is 1, so it just remains 4.208. Okay, now let's move on to the second question there, 2.5410. So as usual, we'll check the 54, check this part, the fractional part, 5410. So that's 54 under 1. There's no difference, 0, so we just leave the 0. 54 under 1, that's 3.475 times 10 raised to the power of what? Can you see 2 here? We take that 2 as the power. So times 10 raised to the power of 2. So that gives us 347.5. So 347.5 is our answer for 2.5410. Okay, so I want us to now talk about calculations in logarithms. But before that, let me give you some governing principles. So for logarithms, when you want to calculate, you want to use logarithm tables to make calculations and then get your final answer, you need to take note of these key rules. Now, when you have a multiplication and then you find the log of those numbers, you should add the logarithm of those numbers. You should add. Then when you have a division of two numbers and you find the logarithms of the numbers, you should subtract. Now, when you have a number raised to a certain power and then you find the logarithm of that number, you should multiply by the said power. Don't worry, when we take examples, you would understand these rules further. Then when you have the roots of that number, you have the nth root of that number, you should find the log and then divide by that root, by the roots that you have. So these are just the main key rules that you need to take note of. They are closely related with the laws of indices. Okay, so these are some of the key principles you should take note of. So I want us to understand also that after you're done with all the calculations, you need to change back to you need to convert the logarithm back to an original number using the antilog table. So that's why we started with, how to use the log table, how to use the antilog table, and we put it all together in the calculations now. So example 1, we want to evaluate this. Can you see that expression there? We want to evaluate everything here. Now I'll go straight to the tabular form because I think it's important that you set out your logarithm work properly. Don't just write things, don't just try to write it in a shabby way. You should set out your work properly. So we're going to use a table here. Now we put a column for the numbers, and the column for the logarithms. Now the third column we would use for calculations. So let's write out the first number, 17.83. If we put that in standard form, our characteristic will be 1 point. We'll check 17 on the 8 difference 3. You can check yours to confirm. 17 under 8 difference 3 would give us 2511. So that's how we got that. Then we bring in 246.9. Our characteristic here will be 2 points. If we put that in standard form, it will be 2 points. Then we check 24 under 6 difference 9. That would give us 3925. Now, like we said, multiplication would change to addition when you find the logarithms. Please take note of that. So when we add this together, we should have our numerator as 3.6436. Okay? We should have 3.6436. Then we take that to the third column. We're done with the numerator, so we take it to the third column there. Now let's go to the next set of questions, the denominator now. So 256.2 would have 2 points. Then you have 25 under 6 difference 2 in the log table. You can check it out. Should give you 4085. Then we move to 3.28. We're multiplying by 3.28, and that becomes 0. It's in standard form. That number is already in standard form. So characteristic is 0, and then we check 32 under 8 in the log table to give us 5159. So by the time we add, remember that it's multiplication, so we add. By the time we add this together, we should have our denominator as 2.9244. So we take that denominator also to the third column. Okay, so we have numerator and denominator now, they are to be divided. So we bring down the value that we got for the numerator, we bring it down from here to here. And then what are we going to do? We have this sign is a division sign. When you have this all over, it's a division sign, right? Now, remember that our law, division, when you have logarithm, it should be subtracted. When you have logarithms, they should be subtracted. So we'll do a minus here. Okay, we'll do a minus here, and that gives us 0.7192. Now, this is by no means your final answer. This is not your final answer. You still need to work on this value by finding the antilog. Okay, by finding the antilog. So we use antilog tables and we check this part. We check 7.1. We check 7.1 on the 9. Difference 2 in your antilog table. You can check that to confirm. And then you get 5.238. Of course, it's going to remain 5.238 because the power here is 0, so 10 raised to the power of 0 is 1, so it remains 5.238. Now, this topic is not difficult. The key thing here is to try to always remember the rules that when you're doing multiplication of two numbers and you find the log, it should be added, and when you are doing division of two numbers and you find the log, they should be subtracted. Okay, then remember that you need to change back to a normal number. Let's take another example. This would involve cube, square, and square roots. Okay, so let's look at the first number, 36.12 cube, right? Okay, let's change that to logarithm first. We should have 1.5577. Now remember that when you have raised to the power of a number, you should multiply the log by that power. Okay, so we have cube here, it becomes multiplication by 3. And remember that if we're going to check this in the 4-figure table, this is going to be moved once to be 3.6 in standard form, so our characteristic is 1, and to get the fractional part, the mantissa, we check 36 under 1, difference 2. So please check your logarithm table and confirm that this is 5577. So when you multiply by 3, you should arrive at this. Then 750.9, okay, you would have 2.8756. So you move the point 2 times here, so 7.509 is in standard form. Then the times you move the point there 2 times, you move 2 times, so that'll be 2 point. And then if you check 75 under 0 difference 9, you should have 8756. Please check all these values and confirm. So multiplication changes to addition once again, and we have 7.5487, which we take as our numerator to the third column. Okay, we take that to the third column. Now let's go to the denominator now. 113.20 square, if you check that in standard form, it will be 1.132 times 10 raised to the power 2. So if we move the point 2 times, our power here, characteristic here will be 2. We check 1 under 3 difference 2, we should have 0.539. Now this raised to the power of 2 should become multiplication by 2, so times 2, and we get 4.1078. Now let's move to the other part, times square root of 92.5. So we check, this becomes 9.25 times 10 raised to the power 1. So we have 1 point. We check 92 under 5, 9661. Please confirm. Now, the square root sign here means, of course, it means square root here. It should change to division by 2. Please take note of these laws I gave you, the principles I gave you at the beginning of the calculations. They are very important principles. So this should change from square root to division by 2 after finding the logarithm. Okay? So by the time we divide this by 2, we have 0.9831. Now remember that multiplication changes to what? Addition. So we add these two values together and we get 5.0909. So our denominator gives us 5.0909, and we can take that to the third column and we have 5.0909. Now we bring down this, let's bring down the numerator closer to the denominator, and we remember that this sign all over is division, so that should change to negative, minus, right? So let's subtract these two, numerator and denominator. Let's subtract, so we have 2.4578. Okay, 2.4578. And when we find the antilog of 2.4578, remember we check this fractional part, 4578, and we should have 2.869 when we check 4578. Then remember that this tells us what power to multiply to raise 10 to, so times 10 raised to the power of 2. Okay, so that would give us 286.9. That should give us 286.9. Okay, so I want you to if you've been watching and you haven't been checking your 4-figure table, you can go back and pause. By the time I bring out the answers, I want you to pause the video and check. If you've not been doing that, you can do that so that you can actually follow and understand each step. Okay, it's important that you do that. You can pause the video, check your 4-figure table, confirm that you're going to get the same thing I arrived at, and then you can play and continue, watching. So we'll take a quick summary of everything we've discussed. We talked about standard form, and I think in grade 9 you would have been exposed to standard form, but if you haven't, then I think to an extent you know that standard form involves expressing a number as, in the form a times 10 raised to the power n, and then a should be a number between 1 and 10, and n should be an integer. Okay, so we looked at some examples. Then we also talked about how to use the logarithm table. We talked about, okay, what is logarithm, and then how to use the logarithm table, and also how to use the anti-logarithm table. Then we talked about the principles. That there are 4 principles I gave you regarding the calculations involving logarithms. So please take note of those principles. Then we now moved on and used them to look at some examples. Okay, so that's the summary of what we've done today. So I want you to practice. So I just gave you one question here, but if you can, you practice some on your own. You can also visit quizzes.com. Just practice. It's very important. And I want you to try to research about the relationship that exists between indices and logarithms. You'll find some fun things to observe if you do that research. But also try to solve the first question you can see on your screen, and please leave me a comment in the comment section about your answer. Let's see if you got it right. Remember, if you have any questions or anything to ask, or anything that you don't fully understand, you can let me know in the comment section also. Okay, so in our next class we'll talk more about logarithms. We're not done with the topic yet. This is an introductory class, so we'll talk more about it, and we'll see how far we can go. So it's been lovely. It's been awesome talking to you guys again today. I hope you continue to have a lovely day. Do remember to share the video and like the video. Leave me some comments, okay? And please subscribe. Tell your friends also, okay? Tell your friends as well. So I hope you continue to have a great day. I'll see you guys same time next week. Bye-bye.